Welcome to all you new people that are just joining us for the first time today. This is an awesome session to join us for. You're going to get a lot of really great information about CEE and RSI in general, and just skills that you can take back to the classroom and to your extracurriculars. So, thank you so much for joining us. We're going to go ahead and get started, and as people join in, we'll keep dropping links in the chat for, our website and all that. So welcome to Real Science, Not Resume Science. This is our November 19th final webinar of the fall season. I'm so happy for you all to join us. We're going to go ahead and do a quick overview about our org and our programs, and then we'll jump right in. So first, about the Center for Excellence in Education, CEE. CEE was founded in 1983 by Joanne DeGennaro and the late Admiral H.D. Rickover, who is the father of the nuclear navy and civilian uses of nuclear power. Our mission here at CEE is to nurture high school and university scholars to careers of excellence and leadership in science, technology, engineering, and mathematics, or STEM, and to encourage international collaboration between and among leaders in the global community. Here at CEE, we have four flagship programs, the first of which is the Research Science Institute, or RSI. RSI is a highly competitive 6-week summer science and engineering program open to rising high school seniors. Juniors are eligible to apply. RSI is the first cost-free summer science and engineering program that combines on-campus coursework in scientific theory with off-campus work in science and technology resource. Just a reminder for all of you that might be interested in applying for RSI for this upcoming cohort, the deadline for the application is December 10th. That is really soon. Next week is Thanksgiving over here, so you only have about 2.5 weeks to get it together. So please, 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 if you have started your application for RSI or if you've been working on getting your recommendation letters and other components for your packet, please work on completing that because December 10th, there's no ifs, ands, or buts, no exceptions on late submissions. Okay, so December 10th, keep that in your brain. Our next program that we supply is the USA Biolympiad, or USABO. USABO is the premier biology education and testing program for high school students. It provides the motivation, curricular resources, and skills training to take them beyond their classroom experiences to the level of international competitiveness. Since CEE began administering the USABO in 2003, every member of the USA Biolympiad team has medaled at the IBO. Applications for USABO have closed already. They are no longer accepting applications. The registration window has closed. If you come across a link that still lets you into the registration mainframe, please just ignore that. Any late submissions will not be counted in the registration. So registration for next year has closed. Finally, the last two programs that we have here at CEE are the Teacher Enrichment Program and STEM Lyceums. The Teacher Enrichment Program, or TEP, provides opportunities for middle and high school teachers to connect with leading experts from industry and academia, explore cutting-edge research and development, and make meaningful professional links with direct benefits for teachers and students. While STEM Lyceums, us, is a virtual club for high school students to meet once or twice a month to learn about STEM career pathways from leading field experts. Industry professionals share cutting-edge research and offer unique learning experiences like scholarships and internship opportunities for high-achieving students. So thank you all for joining us, and if it's your first time here, you're in good company. Questions that do not get answered in the Q&A because of time limits, I usually ask the speaker for their answers to those questions, and they'll send them in text form in the recording email. So that's another thing that you should know about. Okay. Thank you so much for sticking with me on all those questions. And yeah, I'll get to all the questions in a little bit. I'm just going to go ahead. We'll jump into the introductions, and then we'll go from there. So thank you, everybody. All right, so it's my pleasure to introduce a fabulous, fabulous speaker to you all, someone near to peer and someone that you could really look up to. So today we have Uma Sthanu. So Uma Sthanu is an internationally recognized young scientist at the intersection of computational biology and neuroscience. She earned top honors at ISEF 2025, winning the inaugural Mary Sue Coleman Award for Life Science Innovation and a first award in Biomedical Sciences, and was selected for RSI 2025. Her research spans wet lab and computational domains, from culturing neurons to studying regeneration to building mathematical models of disease progression, ISEF 2024 Grand Award in Mathematics. to applying single-cell RNA sequencing and deep learning models like GeneFormer and SCGPT to predict astrocyte to neuron reprogramming. Beyond the lab, Uma mentors peers, speaks on the importance of resilience and curiosity in science, and has excelled in DECA ICDC, winning multiple international awards in business administration, financial operations, and professional selling. Coupled with high academic achievements, she exemplifies how curiosity, persistence, and innovation create impact. In the CE webinar, she'll share how to do research and how to approach it with purpose, creativity, and resilience. So, thank you so much, Uma. I'm going to let you go ahead and take over from here. We're so excited to hear from you.
Thank you so much for that introduction.
Well, someone had asked, is STEM Lyceums open to international students? Yes, STEM Lyceums is open to all students. And then we also, as part of our STEM Lyceums and TEP newsletter, we take article submissions from students as our student news correspondents. So if you're interested in a role similar to that, you can always sign up in our interest form and then just email STEM Lyceums. This recording will appear on YouTube probably in a week or so. So yes, they'll be posted on YouTube and I will directly email you the YouTube link. So thank you for that quick, brief intermission, and we're going to go ahead and get started. So once again, thank you, Uma. Go ahead. The floor is yours.
All right, here we go. So let's see. Okay, so kind of going over quickly what I wanted to discuss today. Thank you guys all for tuning in again. Um, and today I just kind of wanted to share a little bit about like how to get started with research and what kind of things to be thinking about as you're setting out on this journey of doing research as a high school student. So as someone who's been on this journey myself and who's had these experiences and been able to go on this path, I just wanted to share those experiences and my biggest takeaways with y'all. So first of all, I wanted to talk about like finding your why or your purpose behind why you're doing research. Then go into how you create something that's, kind of high quality research and what that means. Then I wanted to talk more about kind of how to build a project you love and can really be happy with, how to communicate that project well and how to communicate your results, how to kind of get all those and kind of talk and address like all the big wins, right, that we hear about with like ISEF and other big science research competitions. And last but not least, of course, answer some of y'all's questions. Okay, so first, a little bit of background. So much of the things I'm going to share today are kind of building off of my own experiences and my journey with science research. So in terms of research, a lot of my work, as Rebecca already mentioned, has been focused on computational biology and that along with neuroscience. And so how can we use all of these computational techniques to analyze neuroscience, and come up with new insights in that field? But I have also done some wet lab neurobiology research, so I have that wet lab experience as well. And in that kind of wet lab sector, my main focus was neuron regeneration, which is a project that I am extremely passionate about, a topic that I really care about, and kind of this huge, like, unsolved issue in the medical field. And the kind of results of all of that work were, of course, being able to be at ISEF for 2 years. And what that really allowed me to do and how that kind of shaped all the things I'm going to be telling you today is it gave me so much exposure to the amazing work that's being done by high schoolers across the world. And so that, again, kind of shaped all of these takeaways. And last but not least, I was RSI 2025. Again, amazing program. As Rebecca mentioned, if you have started that application, I highly, highly recommend that you apply, try your best on all of those things because it really is an incredible application. If you're younger than a junior and you're thinking about applying, highly encourage it. That really kind of shaped who I am as a researcher as well. Starting off, I just wanted to take a minute for you guys to kind of reflect and think about you're on this call, right? You're obviously interested in doing research for some reason or the other. So I want you to think just about what your why is, right? Why is it that research is what you want to do? Why are you here in the session trying to learn about research? So just a moment to introspect, maybe write this down. What is really your purpose with this? Is it that you have like a problem that you're really interested in, some kind of personal connection, some curiosity about, how something works in the world around you? Is it your desire to create something and engineer a solution to a problem that you've been facing? Is it kind of getting into these programs like RSI and other things? Is it college admissions? What is really driving you to be here today? So take a minute, think about that, and then we'll go from there. The kind of reason why I wanted to bring this up and really have you guys think about why you want to do research in the first place is that this why, right, this purpose really does beat what you actually do and what you actually plan to do, right? So doing meaningful research is incredibly difficult. It takes a lot of time. It takes a lot of failures, a lot of resilience. You need to be able to really invest a lot of time into something, have it fail, right? And then be able to redirect and try again. And that kind of resilience I've found is really best done with intrinsic motivation and with just really caring about what you do is just the most important thing. So, in other words, if this project that you're thinking of, if it's something that you would do with absolutely no audience, then you have found the correct project for you. And likewise, if you would do science even without the idea that, it'll help you boost your resume or it'll help you get into a better college, if you genuinely look around you and you see things that make you curious, right? If this is something that really lights your flame and really makes you think and really causes you to like enjoy doing research, then research, I would say, is a really good choice for you. So, and I really think that like thinking about what problem is going to guide you is truly the first step. It's very tempting to say like, oh, this is a very like valuable extracurricular. But then the other thing is you need to be able to talk about your work, right? And a big part of that is being able to show the passion for your work. And I think it's kind of underestimated that, like, and un kind of understated, I would say, that in any kind of conference, competition, there's always like this interview or this presentation, or even in paper writing, right? You cannot convince people of your idea, or like even grants or anything like that. You can't convince people of your idea if you are not committed to it and not passionate about it yourself. So you need to believe in this project and believe that this issue needs worked on. So for me personally, my work was with multiple sclerosis. I've worked a lot with multiple sclerosis, and also with neuron regeneration, right? All of these neuroinflammatory and neurodegenerative conditions. And so for me, the reason why I even begun research in the first place was because my father was diagnosed with multiple sclerosis. And so that was a huge part of my life, right? And seeing that the kind of difficulty that that brought into my own life. And I really wanted to figure out a way to find a cure for him and kind of care management for all the families out there who also have family members who are impacted by this type of disease. And so, me genuinely wanting to solve that problem since I was very young, right, really shaped who I was as kind of a researcher and as a scientist and allowed me to get through all the hurdles that I needed to get through as a high school researcher. So again, as a high schooler, you are going to hear, or even as a professional, if you continue doing this, you are going to get a lot of rejection, get a lot of pushback, need a lot of redirections because sometimes you try something and that path just doesn't work, right? There are times when you try to get resources and that just doesn't work. But if you have a project you really care about, that's really what's going to keep you going. And that's how neuroscience was for me. The computational biology portion of it was, of course, because I wanted to solve all these problems, and also just because I had this like genuine curiosity and fascination for data analysis and how we can actually find these conclusions based on data. So it was a combination of that curiosity and also wanting to solve a problem. And so, with that, I would say never ever underestimate the value of curiosity in basic sciences. Trying to solve like an individual applied problem is an amazing way to go to it, but also if you have something that you're just genuinely curious about, that's also definitely a very valid reason to start doing research, if that makes sense. So, like for example, a lot of pure math researchers are always having to answer the question of what is the like kind of application of your work. And while that's amazing to think about the applications, again, don't underestimate the value of just being curious about something. That's also an incredibly valid reason. So, what makes a work actually high quality for a high school research project? So, this is, of course, influenced by all the different constraints that you have as a high schooler, right? So, you may be thinking, I don't have access to an incredibly expensive lab, right? I don't have access to a lot of equipment. But for a high school researcher, what makes something high quality is the rigor of the methods that you're using. So even if you're not able to do incredibly complex methods, whatever you should do should be like kind of considered good science, if that makes sense. So you should try to kind of carry out whatever methodology you're able to in a way that is rigorous, reproducible, and also that other researchers can build off of um, because you may work on a research project, right? Get to a certain point and not be able to continue from there. Maybe because continuing it needs more resources. Maybe because you're just unable to anymore. Maybe it's because your interest shifts. But the point of making this research high quality and rigorous is that anyone, the next scientist, right, can take your publication, can take your work and build off of it. And that's how you come up with real progress in the field, right? Because ultimately that should be our goal when we're doing research, is really advancing the field scientifically. And so with that, the first few things that I would say to keep in mind when you're developing these methodologies, these procedures, is coming up with a good question, right? Coming up with a clear testable question that matters, right? So come up with a question that really targets a problem or or like an unsolved question, right? Come up with a gap, find your niche. Um, and then you also want to follow all of these kind of good principles of experimental design, right? So that's having your controls, your positive and negative controls as necessary, and also kind of having your question in a way that you have clear variables defined and also measurable outcomes. So you want to be able to define your outcomes and how you're going to analyze error ahead of time, and then use that to create your analyses. Another really important thing is to acknowledge your limitations and your work's limitations. No research project that you do is ever going to be the end all be all cure that is kind of perfect, right? There's always going to be limitations just based on methodological constraints, right? You weren't able to do a certain method. Something was like outside the scope of what you did. There are always going to be limitations, right? Sample size limitations, everything. And so acknowledging those limits, I think what I really want to stress here is that that doesn't make your project less valid. It actually makes it more valid in the eyes of people in academia. And again, this is coming from someone who has worked at different labs, right? Been in academia. Um, it really does matter that you acknowledge your limitations because people will not like kind of accept a work that doesn't acknowledge those limitations. And also at the same time, you want to be able to contribute to the existing body of knowledge that's there, and provide other people when they're looking through articles to be able to see, they said that this is a limitation of their work. Maybe we can try to build on that. Maybe we can reproduce this experiment, and improve that limitation. So by acknowledging the things that need work, you're actually improving the rigor of your work rather than downplaying all the amazing work you've done. And so that's something to really get comfortable with. And that's what really makes something high quality is being able to pinpoint this was the scope of my project. This is what can be done in the future. And last but most certainly not least is reproducibility. This is incredibly important because, again, as I said, you want to be able to have another researcher take this work and really prove it, right? Or be able to build off of it. And so they need to be able to understand the methods that you used. And I feel like this is kind of like a mindset shift. A lot of times if you are doing something as part of like a competition, right? You're thinking of it as like these are like the secrets, my like own trade secrets of how I do stuff, and like the methods that I use, and I'm just going to present it at a high level. But I think that in order to make your work really impactful in the field, you need to make sure that everything is rigorous and clearly defined and be able to kind of justify every decision you make. So that's an incredible thing about science and honestly just about maintaining the validity of science and the validity of high school science, right? Of students in high school who are doing research. If we can kind of establish these amazing practices and follow all these conventions, then we can really show like kind of the potential that doing rigorous high school research can actually have. So, with that, intellectual honesty. So, there's again so much of a temptation, right? I feel like when we are doing these kind of projects, to make sure that we're not downplaying the work that we've done, right? Of course, any work that we do is incredibly difficult. And intellectual honesty is actually one of the principles that will allow your work to be cited by other people, and that will encourage people to build off of it, to share it. It'll help you to be able to become more recognized as a researcher. And so, what does intellectual honesty actually mean, and how can you show it? First of all, like authorship and contribution transparency. So, if you are working in a lab with a mentor, being able to clearly pinpoint what you did versus what was done by other works and that you drew from, that's incredibly important. Another thing that's really important, and that I always like to say, whether you're doing this on your own or as part of a lab or in any kind of setting, when you're designing an experiment, write down all the decisions that you're going to make. How are you going to analyze this data? One that I always use as an example is your sample size, right? So, if you haven't heard of this before, so there's a phenomenon called confirmation bias, where essentially when researchers have a hypothesis, right, and they believe that that hypothesis is true strongly before the beginning of the experiment, then the small decisions that we make day to day in our experiment will actually be altered to reflect that previous hypothesis. So then we're not necessarily proving that the relationship actually exists. We're just proving that we thought the relationship exists, and we're kind of not doing science as rigorously as we should be. And so one of the ways that that can happen is, for example, if you're doing an experiment and your first couple of cover slips don't give you the result that you were expecting, so you keep testing more and more cover slips and keep going, right? Until you finally get the result that is significant. And so the issue with that is if you have a giant sample size, then your chances of mistaking something that's by chance for example, if you just keep constantly taking those samples, then you may be one p hacking, right? You might be just kind of inflating that, and so making the amount of difference that it needs to be significant, you might be making that too large to where it's not like biologically relevant, like the effect size is not actually relevant. So that's a huge issue. And so essentially what I'm saying, where I'm going with this, is what you want to do is you want to think from the very beginning, like this is how much I want to do for this particular run of the experiment, right? Or for example, you may choose to say to avoid like having too many replicates or having pseudo replicates, what we're going to do is just average all the cover slip values. So make those kind of like analysis decisions well ahead of time before you start analyzing the data and doing the experiment. And that way it stops you from making decisions that are actually reducing the validity of your experiment. Because if our goal is to do good science and come up with results that actually matter and move the field ahead, that's what we want to do. And then, of course, log any changes that you make to that methodology. For example, your cover slip breaks, right, when you're doing the experiment. Um, Log that. That goes into like kind of the caveats of that run of the experiment and kind of things to keep in mind. Next, keep a good notebook. So this is really important, again, to maintain that honesty, transparency, and also just rigor, right? So keeping track of everything that you're doing in the lab and when you do it. Again, good for rigor, helps you make your experiment actually be more useful. Next, citation. This is, again, also important to kind of help build this reputation of high school research as incredibly rigorous. Um, So make sure that you are citing all your sources properly. And again, I think this kind of honesty and transparency is not a weakness. It's actually a strength and makes your story a lot more understandable, and also a lot more reasonable. So if you have kind of um, this like kind of not I wouldn't say random, but like unique finding, right, that hasn't been um, backed up in the field, or you're not able to cite that, oh, this is kind of in line with what has been found in the field or with the thread of reasoning. If you're not able to come up with that kind of story that connects your work to previously peer-reviewed experiences, it might be experiments. It might actually be like more difficult to get the reception that you're looking for. So that kind of citation and being able to acknowledge what's been done in the field and how your work fits into it, incredibly useful. And last but not least, we have team projects. So if you are working in a team, you want to be able to kind of clarify with each other what your roles are, what the scope is, and keep that running smoothly. And that, again, also helps with acknowledging everyone's contributions and making sure that you're remaining honest. So why is this important and actually worth it? Again, this is just a part of doing good science, right? And so this all, I think, goes back to that purpose question, right? Like, why do you want to do science in high school? And the goal with that, I think, should always be because research, again, is so difficult. The reason that you should be pursuing this is because you care about it, because there's a problem that you really want to solve, or because there's a phenomenon that you really want to advance the understanding of. So when you're trying to advance the understanding of something or go that step closer to a solution or a clinical trial drug, you want to make that tiny bit of progress towards that goal. You need to be able to do good science, do rigorous science, keep good documentation. Again, make it easier for others to build off of it. Because if you're creating a work that doesn't have that rigor, um, and is not being cited by professionals in the field, then the amount of progress you're able to give is less, right? And while any work is always valuable, I truly believe, and this is kind of a personal belief that's been built from doing amazing programs like ISEF and RSI, that high school researchers have the potential to do so many amazing things in the field of research, right? We have these amazing ideas. We have a lot of curiosity. We have the ability to think out of the box. And so I think from the kind of world of science, um, if we are able to contribute at an advanced level, right, in a way that is rigorous and that is being cited by professionals and that is doing well, that we can actually truly make a difference, right? And so in order to make that difference, though, we need to start with these kind of steps. So again, going with that, high school research done in an authentic manner actually does have the power to make all of these strides, right? So professional scientists, right, the people who are doing research at these amazing universities are making incremental progress towards the goals that we want to reach, right? And I really do believe that high school research can be the same way, right? It doesn't have to be, oh, this is a project that I do for a year, I submit to XYZ competition, right? And then get this result. It really can be an ongoing thing, a publication, a conference presentation that really does have an impact on the problem that you're trying to solve. So, as long as we have that belief in that potential and act accordingly in terms of the rigor of our science, I really do believe that doing high school research has so much power. And then, of course, if research is really what appeals to you and you want to do research as a career, you want to keep solving these problems, right? Doing rigorous science and getting citations and cultivating all of these strong research habits is amazing for your career as a scientist. So I definitely encourage you to think long term, right? And I've gotten this question a lot where the question is kind of how can I do well on these short term things like college applications or high school competitions. But if we shift the focus to the long term, into a career in research or into solving your big cause that you care about, that you want to dedicate your career to. Doing rigorous science is the best way to stop yourself from having to do double the work, right? You don't have to do all this work now and then work on building your reputation as a scientist, you can really start building that reputation as an amazing scientist right now by doing incredible work. And that's great for the causes you support, and for your own career at the same time. So, how do you actually build a project that you love and can keep doing for so long and actually finish? So again, research takes so long. It can take, um, like months, years, to finally get something that you consider cohesive. Even decades, honestly, to get something that you really care about. So, how to get that kind of project and how do you get started with it? Um, I like to break it into three different paths. So, you have the analysis kind of path, you have the engineering kind of path, and then you have a wet lab path. So starting off with analysis, this is becoming increasingly more and more popular as we get these great data sets available. So in biology, of course, RNA sequencing has been taking the world by storm, right? As well as all other kinds of data. You have clinical trial data, you have data on chemical structures that allows you to do drug discovery and things from your computer. And so that is one amazing path to get started with research. Not only does it help you start to understand science and start to understand the process of how do you formulate a research question, how do you do this. Analysis is an incredibly important skill. All the statistical things that you'll learn by doing computational work is going to help you in any other kind of research. And it's also, of course, something that you can do without a lot of resources. So for high schoolers, it has that appeal because um, obviously, I'm sure so many of you have been in that situation where you wanted to solve a problem, but there's equipment needed to do it, there's resources needed to do it, and you just don't have access to that as a high schooler until you're in university. So data sets and kind of exploring that is a great way to still do rigorous science, but do it in a way that's accessible. Next, we have the engineering route. So if you are interested in building solutions to things, then you'll want to try and take this route. So come up with a prototype, kind of do all the testing, define what parameters you're going to use to determine its success, and then validate that on a larger scale. And last but not least, of course, we have that wet lab type of work, right? And so this can be across a variety of different fields, but being able to get access to either laboratory setting or get access to the resources to do certain types of projects that can be done without that kind of regulated research setting. Like for example, like environmental studies or things like that that are approved and allowed to do on your own, or getting all the safety and approvals necessary for things that require those. And so that's another path to go. It's difficult, but a lot of times, for people who like to see the results of their work, in kind of a tangible way, that is a great kind of way to do things. And also, if you have questions and you like kind of doing that controlled experiment and having flexibility over your research question, amazing option there as well. So those are your three kind of paths, right? And when you're deciding what you want to do with that, I really recommend thinking about the resources you have, obviously. So these are all going to take different levels of resources, the access that you have to those, and also just what kind of really inspires you, right? Are you inspired by kind of quickly finding answers, finding results, and making use of these experiments that are already done? Then that analysis path is amazing for you. If you're interested in building, if creating something new, right, and coming up with something that's novel and a novel solution to something is really interesting to you, maybe it's that engineering. And if you're just curious about the way things work, then that wet lab work is for you and experimentation is for you. So once you've come up with your kind of procedure and you've done this experiment, where do we go with the results? So sometimes I've been asked, we have these projects, right, that we work on for 9 months, a year, several years, right? And then we're going to the point of that statistical analyses and we're not finding anything significant. And so they ask, what can we do when we get these negative results, right? When things don't align with our expectations. And again, this goes right back to that confirmation bias. And I always say that there is no positive or negative result. there's only valid and invalid results. So any valid result, right, that was found through a scientifically rigorous process deserves to be shared and presented. And so, like, for example, say you've been working on your science fair project for 9 months, right? And it's, let's just say it's a project working with C. elegans and a drug, right? And seeing if that drug helps C. elegans regenerate after an injury. Say that's your project, right? And you find that the drug actually has no impact on that regrowth, right? You may be tempted to think, oh, this project is a failure, right? It's not a result that you find to be groundbreaking. But what ends up happening is if you say withdraw at that point and say, I don't have a good project, I don't have results, or if you downplay the results of your experiment, what can end up happening is we get this publication bias where the only things that are getting published are ones that are significant results, right? So then let's say 2 weeks down the line, or 2 years down the line, or 2 months down the line, another lab works with that same drug, right? And they find that it does have an impact, right? Then let's say another lab works with it and they find that it doesn't. But the lab that doesn't report the results because it's considered negative, not groundbreaking, doesn't get published, doesn't get written, doesn't get presented. Then what happens is a third lab is thinking, do I want to research this drug? And they see, oh, a publication has found that it is useful. Let's try it again, right? And then you keep coming up with only positive results in the body of literature, and it doesn't acknowledge any of the negative or the like kind of insignificant results. So if you only consider results that are statistically significant and not the insignificant ones, then what you end up doing is coming up with this kind of um, overstated result. And then you can end up with resources being wasted later on. And when you first get to trials, it can end up being kind of like not can end up being harmful or toxic because the previous results weren't actually shared. And so those are the kind of things that when we say we want to do good science, we have to keep in mind is that we're contributing to a body of literature, right? We're contributing to something that is already existing, right? And so we want to be able to put something out there that is going to contribute and that is going to lead to even better things being done in the future. And so a huge part of that is reporting all the results you get, even if it didn't align with your hypothesis, because that can actually tell us something new about what we're learning. So focus on the rigor, focus on is the science valid, is it invalid, and not on is this helping me prove my hypothesis. Because something that comes up with an unexpected result is incredibly fascinating, gets a lot of attention, but something that comes up with a result that maybe you think of as like not advancing the field as much might actually advance the field by proving that this needs to be investigated more, if that makes sense. So how do you make sure that you followed all these principles, right? How do you make sure that you actually communicate the work that you've done in an honest fashion? So what you want to do is really acknowledge how your work fits into what's been done before. And so you start with that literature review, right? You start with reading what's going on in the field, what other past attempts have been made to solve this problem. And with that, you formulate your problem statement, right? Where are the gaps? Where are all the things you need to work on? And kind of integrate that with the prior work. Next, you want to come up with a hypothesis. This can be based on that prior work, right? Come up with what you expect to happen. Then you want to design those rigorous methods, and then your results, and then, of course, your limitations and your next steps. And those limitations and next steps should really acknowledge, again, how your work fits into what has been done before. So this is a step that's often overlooked. Once you've done all your analysis of your results, too often what people miss is that what you next need to do is see how those results fit into what's been done. How does it corroborate what's already going on in the field? Next, what you want to do to help to actually communicate all of these things in an interview, you want to be able to answer the questions of so what, So what the scope of your project's impact is, and also what failed in your project. And you want to be able to answer them both in a manner that is honest and transparent. So the so what question is about kind of being able to communicate the impact of your work um, in a way that does not overstate and does not understate. So you want to be able to kind of identify what the direct impact of your work is and what the kind of impact on the broader community as a whole is. So start with the impact on your field. So within the field, you finding a specific result might change the way other scientists experiment with something in the future. So think about what impact that has on the field. Then after that, you can think about on a very preliminary level, what does this work accomplish for the people that are impacted by this problem? And you want to think about directly and again, also future impact. And also make it very clear when you're communicating the impact of your project, which of those impacts are the direct impact of your work and what are the impact of the work that other people will do based on your work. In terms of what failed, again, acknowledging those limitations so often, we can tend to think of it as like a weakness, but it really isn't, right? It's part of doing good science, and it's what helps take you further as a researcher. And so, what about the big wins, right? This is what a lot of times high school researchers want to know is how do you really take this and get those big wins from it? How do you take the research that you do and get that recognition? And what I like to say is you don't plan for these things, right? So again, going to like ISEF and these kind of research competitions, so often it's about communicating your project with passion. And you don't get those wins by being passionate about winning the competition. You get it by being passionate about science in your project, right? So don't try to plan for these very short-term type of wins, right? Or these short-term accomplishments. With your research, what you really want to accomplish in the long term is making an impact on the field, right? Changing the field, solving the problems that you want to solve. And so if you really dedicate yourself to doing those things, then these program acceptances and these competition wins will kind of come naturally, right? They may or may not come. And there's so many different factors that go into that. But the best thing that you can do is really do good science, right? And really care about what you're doing. And that's the kind of thing that you want to communicate. So again, with that, let your passion for science lead your results. So don't think about, I need to do a project with winning this competition in mind, because then it might be really tempting to work in an area that you don't really care about. So there are a lot of like buzzwords right out there that you think, oh, this is the kind of problem that always does well at XYZ competition. But if that problem doesn't really drive you as a person, if it's not something that you want to be a larger part of your career, that you're not genuinely curious about exploring, then you may be using your time and your energy and your expertise, right? Because it's valuable towards something that you don't really care about. And it's so difficult to do good work in something when you don't care about it. So you may end up putting a lot of effort into something that's not really going to yield good results for the future. So I really do believe that starting with the passion is the way to go. That is what matters at all levels and can actually take you far, both in the short term in your high school career and further on, right? I really do recommend thinking beyond buzzwords and thinking about what really matters to you as an individual. Um, and then that recognition, again, may or may not follow. And also, it takes time, right? And I think that's one of the reasons why I stress passion so much, is because these things can take a lot of time to really come into fruition. Okay, and with that, I'm going to go ahead and look at the Q&A. Um, Looking at what we have here in the Zoom, we can look at that first. Rebecca, would you like to moderate or I can do it? Either way works.
Sure, I can go ahead and jump in. And then I also have some of the questions that you received through LinkedIn also pulled up,
Mhm.
so we can bounce around between the
Perfect.
two. Okay, so I'm going to start with Samaya's question. So, when did you start your research journey and what did that look like?
Yeah, so I'm happy to answer that question. So I have been doing, I think the beginning would probably be I started doing science fairs when I was very young. So in like early elementary school. And I started just exploring like the world of science and I got really curious about learning how things work very early on. Um, and then as I got a little bit older, right, I started thinking about like I realized what like a powerful avenue research was to solve problems, and I started thinking about again like my own life and the problems that I face as a person. Um, and that's what really led me into all of this work with neuroscience and with multiple sclerosis. Again, that personal connection to it. So, I started as just kind of being curious in general, like very young. And then I would say when I started doing the work that I'm kind of continuing now, that was around my sophomore year in high school was my first time I made ISEF and had that kind of research journey, and then started doing a lot more rigorous work in neuroscience. And so, yeah, I mean, my path was again, really driven by wanting to find something that mattered to me. And then taking that passion and that curiosity from a young age and channeling it towards a solution that I saw.
Awesome. And that kind of streamlines into this question that just came in, which is passion seems to be a huge thing for, this presentation and what you're talking about.
Mhm.
Are there any other big main takeaways that you think we should keep in mind for the future researching?
Yeah, so I would say along with like being passionate about your project, right? Another really important thing that I always like to keep in mind, especially if you're new to kind of the field of research, is being really open-minded, right? And being willing to learn and take suggestions from other people and learn from your own failures. So when you are doing research, again, you are going to face rejection, you're going to face pushback, you're going to um, kind of get a lot of feedback from the world around you, right? Whether that's from judges at a competition or that's from your mentor who's telling you based on their experience that something may or may not work, or if you are kind of facing any kind of pushback or anything like that, just being open-minded. I think it's kind of not talked about enough how much research is a collaborative field. And I think as a high school researcher, it's like very tempting to get siloed into your world of research and the exact project that you're doing. But science really is collaborative, and it's just it's amazing that and that research is a community of people working towards a set of goals, right? So even if you're not directly working with someone, you are working towards similar things and you want the same thing out of it. You want progress for society, right? And you want a better life for patients if you're in bio, or you want better sources of energy in different fields. And so I think having that kind of open mind, um, really absorbing what other people in the field are saying and being very open to criticism is just one of the best pieces of advice I can give you as you're getting started.
And with that in mind, I'm going to move into one of the LinkedIn questions. It says, my parents are not really into science, and I don't get very much guidance on science research from them or from my high school teachers. How can I start my science research without help or organically on my own?
Yeah, and so I mean, for context, like with my own kind of journey, neither of my parents are really into science, right? And my high school is not one of those with like a very streamlined, like formal research program where you have a class for research, and they give you that framework. And so I think what really helped me to get started was um, I was a reader. I was consuming scientific literature all the time. I would, when there was something I wanted to know, I would go down rabbit holes. Again, that willingness to be able to take the time and really commit it to learning and being curious. I think was what really helped me. So I would say, like, if you really don't know kind of where to start, start with the problem that you want to solve or like a niche that really interests you. So, for example, um, you may be really interested in, I'm not going to do neuro because I've talked about it so much so far. You are really interested in, for example, space, right? Let's just say you're really interested in learning about astrophysics, right? Think about what are the problems that are unsolved in that field, right? And really just read about it. Like I would say, start at a very high level, look at literature reviews, right? Narrative literature reviews to begin with. If you're not familiar with the vocab of the field, read some narrative literature reviews. And then slowly move into individual experiments. Go to the bibliography of those literature reviews and click on studies that interested you. Really start with that reading, and get used to that process of absorbing literature, I would say is an amazing first step, right? And so I think, again, reading like high level literature can at the beginning feel incredibly intimidating, especially if you have no exposure to the field previously. And so I would say, like, start with being very comfortable not knowing all the words on the page, right? Be very comfortable only understanding maybe 10% of the flow, and really dissecting these things, like searching up words you don't know, kind of, again, being willing to put yourself into a situation where you know the least, right? So I always say that you're learning the most if you're in a room of people where you know the least about something, right? So that you can absorb that information. And so I would say the first step is really start reading papers, start reading, and start kind of learning about the field you want to do work in. And then that can help you to understand what are the biggest problems here that need solving and what are the biggest gaps.
Awesome. This next question, I'm just gonna kind of summarize in groups since we have a number of them that are kind of similar. So
Yeah.
can you speak a little bit about how you approach your research timeline and then also maintaining a balance between schoolwork, extracurriculars, college applications, all of that? What does that look like for you?
Yeah, so I, over the past couple of years, have done research a lot over the summer, but also throughout the school year. So even my wet lab research work that I do in the afternoons, after school, and it's something that I make time for. And again, that's why I say, like, choose a topic that makes you lose track of all time, right? In a way, because this is going to take up a lot of your time, and it should be something that you're able to be committed to, right? For research to be something that you are able to be a part of, right? Something that you are able to say that you meaningfully contributed to, it does take a lot of time, right? And it does take a lot of that balance. So you may be spending 15 hours in a week on research, right? And so the way that I kind of found that balance between like schoolwork and that was really just a lot of like time management, a lot of prioritization. And honestly, I like live, eat, breathe research, in science, and I enjoy it. And so I end up spending a lot of breaks and things like that on it. And so I would say if you're thinking to do research as something you're really passionate about and you care about, then you end up making it a priority.
Awesome. And can you go into a little bit more depth of your experience with RSI?
Yeah, absolutely. I love talking about this. I love RSI. RSI, I learned about RSI when I was at ISEF in my sophomore year. So that was May of my sophomore year. I had met some older students, right, who were saying, "Oh, are you going to apply to RSI when that application comes out? It's going to come out in the fall." And I looked in the program, absolutely fell in love. So for those of you who don't know, RSI is one of a kind, right? So there are a lot of these kind of high school research programs out there, but RSI is the one that is completely all expenses paid. And they really invest in you as an individual, is what it is. And one of the things that makes it amazing is that you're really meeting the future leaders in STEM and in science. So it really cultivates that community. And it's also just an incredible experience for like being exposed to a lot of different fields, being able to attend guest lectures with incredible people in across a variety of fields, being able to do meaningful research and contribute to a real project. And so my experience with RSI was that I found just this incredible community of people who, again, just absolutely love science. And it also taught me a lot of incredibly valuable skills. And so if you, again, if you're considering like applying, please do. And I would say it's an amazing program for people who really love science and care about doing research.
And can you clarify, because I saw this question come in, was your RSI project a continuation of your ISEF project, or did you start fresh with a new idea?
Yeah, so it was not a continuation of my ISEF project. It was um, a part of a computational biology effort that was going on. I created a computational biology project based on single cell RNA sequencing, whereas my ISEF project was wet lab neurobiology. So it was somewhat related to Alzheimer's, neurodegenerative diseases, but completely different skill set. And I think one of the biggest things that I learned throughout the course of doing research, right? Is again, like I was saying, you learn the most when you're put in situations where you know the least. And I was completely new to computational biology, right? Like I didn't know how to program using R. I didn't know how to do all this data analysis. I didn't know how these kind of pipelines worked. And so I would say that that kind of pivot taught me a lot about a new field. And so it was not the same project.
One thing that I've just been kind of gushing internally about is that you're such a fabulous public speaker. Can you give us a little bit of advice or feedback for some friends? One of the questions we have here is, I love doing research, but I'm working on effective speaking skills. I have anxiety and stage fright talking in front of people. How can I balance using technical language and personal language when sharing my projects?
Yeah, absolutely. I Honestly, I think that like that communication skill is so important, right? So you have this work that you've worked on for so long. How do you actually communicate that? And I think that the best way to do that is one, stay very kind of true to your project and what you've done. So I think like really being able to focus on what clearly define like what the scope of your project is really helps you to get over those nerves. So one of the best pieces of advice that I ever got from a fellow kind of friend at ISEF was she was telling me how she never gets nervous about those kind of interviews because if it's in the scope of her project, she knows how to answer it because she did the work, right? And if it's not in the scope of your project, just be honest and say it's not in the scope of your project. And I think that piece of advice has stayed with me for so long. And it's something that I really try to implement, even beyond just competitions, but in general, when talking about my research, is if it's within your scope and it's something that you truly did, then you should be able to answer it, right? If you're able to kind of stay true to what you've done. And if it's not, then treat every conversation you have as an opportunity to go back to the lab and write that idea down for next time. You know, don't take it as a failure. And I think that mindset shift is what really helped me to get better at those kind of interviews. In terms of that balance between technical and personal language, what I really like to do is start off by defining the project in real world terms. So, like, what is this project actually doing for the real world? And then during the methodology and things like that, you can get a little bit technical, but bring it back again to how you see these changes in the real world. I think that kind of framework actually helps you to be able to keep that balance between technical and non-technical.
So you talk a lot about, really that authenticity of, knowing your project and, having using your passion to ignite how you can communicate about your project. One of the questions over here that came in talks about using AI and large language models as kind of that aid when generating, working on like your language and research. So do you have any thoughts about like the use of AI in that capacity?
Yeah, so of course, this is something that is just like shocking the field of academia, and it's a kind of a big, it's having a huge impact. And of course, like your standard competitions and things like that, always have rules that this is not like no part of anything can be written by AI. And then journals have their own policies about it, but generally it is always that the use of AI in the writing process is not allowable. And one of the things that I think makes that kind of very valid is that, you know, being able to write and communicate every sentence in a scientific research paper is backed up directly by a vetted peer-reviewed paper, right? Every single sentence that you see on there is incredibly carefully crafted based on those facts. And AI as it is now is not doing as good a job as being able to cite every fact that it says, right? Or being able to synthesize that information. And I also think that kind of a really important part of research is being able to think creatively, right? Being able to think and synthesize information and analyze them in a way that's kind of creative and adds a new spin on things. And so what AI does is it reads from the past, right? It goes only based on the past. So we can't come up with new or novel ideas using something that can only draw on the past, right? So that really does require that human curiosity. And so for that reason, I really do believe that kind of old-fashioned reading these works is really the best way to go.
Awesome. Going back to what you were talking about like developing authentic community.
Mhm.
One of the questions here is, I've pursued my research as much as I could at home, unassisted. Um, is there any way to connect with my goals, when I come from like a rural area or might not have that like large network of people to draw from? Or do you have any resources that you could share?
Yeah, absolutely. I think if you have completed as much as you can do at home, um, it I mean, one thing, if you don't have any like kind of labs in your area that you can really keep working with, I really do recommend you look at programs like RSI, right? Any kind of programs like that that will allow you to get access to these labs and things like that. And I understand what you mean, why, there is kind of like that point where it's difficult to move forward with a project. For example, if you do computational work, you may get to the point where you need wet lab validation, and those are difficult to get, right? If you're in an area that doesn't have a prominent university or doesn't have a big research program, I would highly recommend looking into places that are going to allow you to do that. Or if you're able to, you can even work on getting this work that you have, that analysis done in a way that's rigorous enough to be published on its own, right? So again, so much of science is really incremental. So if you're doing, for example, an RSA sequencing kind of experiment, right, and seeing the impact of a drug on the cell profile, right? And you're thinking the next step for this is really to do the wet lab validation, and you don't have access to that wet lab, it may be possible for you to do more analysis, make sure you have a big enough sample size, and be able to publish a paper that does incremental progress. Progress is not, made all in one paper. And so I would recommend really thinking about how you can take the resources that you have right now and the work you have right now and make that rigorous enough by just performing more analysis and really doing as much as you can.
Awesome. So I think we're getting tight on time, so I'm gonna go and kind of lump the last question together because it's
Okay.
kind of a biggie. Everybody asks this same question, which is, how do I get into RSI? Do I need ISEF? Do I need to be a competition winner? Do I need USABO to get in?
Mhm.
Which I can add in a little bit of information on this too, but well, you could go ahead and just take
Yeah,
it.
so I mean, obviously, I'm not an RSI admissions officer, right? I don't work for CEE, but I can tell you, based on my experiences of seeing people who have been in this program for the last few years, um, that, what RSI and what I feel like it really looks for, and correct me if I'm wrong, is just passion for science research. It's potential and it's passion. Those are the two things. I'll say, like out of my cohort, I can tell you that certainly not everyone had ISEF, right? Not everyone was an Olympiad winner, right? Um, you may see some kind of correlation between the two that like for example, you know a couple of ISEF kids and they both got into RSI. But a lot of that is correlation, not causation, because the students that are doing well in those competitions are people who really care about science and research. And so I think RSI really looks for who are the people who are demonstrating that they have specific problems that they really care about, right? Who are people who are going to go on to become the researchers and the leaders of tomorrow, right? And so I would say don't worry too much about do I have the impressive enough profile to get in because it really isn't about checking boxes, if that makes sense. And likewise, I know that there are plenty of people who have won Olympiads and who have made ISEF and done well at ISEF who have not gotten RSI, right? Because the programs are different, right? No award or any kind of accomplishment is going to guarantee that you're going to get RSI. Because ultimately, RSI is the Research Science Institute, right? They don't just want these incredibly high achieving smart kids, they want incredibly high achieving smart researchers, right? Who are going to apply all of that skill and that talent towards research and science. But I'll go ahead and let you wrap that answer up because you probably have more of an insider view of this.
Thank you, because that question comes up a lot. So, as Emma said, it comes down to that passion and that authenticity, right? So, um, you could say that we look for students that are well-rounded or students that are gifted in science, but what it really comes down to it is whether or not you show passion for what your research is, that you've been active in trying to pursue your goals, that you communicate yourself well, you conduct yourself well. And, like Uma said, that you might have competition wins, you might not have competition wins. Um, it really just comes down to person and just how you meld and how you present yourself and communicate your ideas. Um, Selection for RSI is done by committee. And so it goes through multiple like series of evaluations. It's even not even done within CEE. It's outside of CEE. So it's double blind. It's tested. It's proven to be a quite a rigorous like selection committee. Um, and there are things that, we look out for that just add that little sparkle. Like, do you do ballet? Do you play guitar? Do you, have a passion for your family? Are you a cook? So, it's not a one size fits all when it comes to RSI. It's that melting pot of skills and communication and personality and everything. So, there's no way for us to say, if you do this, you will get RSI. It's just,
Yeah, and
it's just one of those things.
I'll also add that like I do believe RSI does consider like what opportunities you have and like what you've done with what you were given. Right? So like with that passion, like if you're thinking, "Oh, I haven't had the opportunity to do this kind of research, maybe my application isn't good enough." Just know that like any kind of program that you do is always looking for, did you have the passion to pursue this project with whatever resources you had, and did you really try to make those opportunities for yourself? I think is a big part of it.
Yeah, absolutely. So like for an example would be, you didn't participate in USABO, but did you start a biology club at your school because there was no biology club and you wanted to show that you had passion for that and wanted to start a community around biology? That would be an example that about leadership and passion that I could give. But yeah, so um, I hope that gave you all some clarity about RSI. I just want to reiterate really quick that the application for RSI is due December 10th, so about 2.5 weeks. And last minute submissions and overdue submissions not considered. So please make sure that you're very thoughtful and purposeful if you are applying for RSI this year. Uma, thank you so much. We're going to transition out into our thank yous. So I'm going to pull up our little sponsor slide. So once again, thank you to Uma for presenting. It was great. It was an awesome closeout. Thank you all for attending. This was a great turnout. I hope you all enjoyed the information that was shared. I'll make sure that for these extra questions that we haven't answered, that we pass them on and then try to get those answered with the recording that will come out. Thank you to our sponsors. Without them, we would not be able to keep this cost-free. Especially thank you to the Claude Moore Charitable Foundation. Um, Once again, thank you to the audience for joining us and making sure this program is awesome. And thank you to our speakers and our Rickoids that join us very consistently to share the knowledge and share the love. So thank you all. STEM Lyceums is going to be back in the new year. We're on break for December and Thanksgiving. Join our mailing list using this QR code to get up-to-date information and the registration links. Just like this past fall, we'll be sending the registration links collectively for the entire spring, so you can pick and choose which sessions you're interested in. We have an incredible lineup, a lot of competitions, a lot of competition winners joining us to share what it was like. We have a lot of career talks coming up around coding, cybersecurity, computer sciences, engineering. So a lot of topics that y'all asked for. So thank you all again. Scan the QR code to get the interest form. The link is also in the chat. If you just want to click on that link, that will sign you up for the mailing list. If you are a repeat customer here, you are already on the mailing list. So thank you.